Okay, so this is sugar. That's a covalent compound. You can see the sugar crystals. This over here is table salt, an ionic compound. The other one's covalent. And so they don't look all that different, just the crystal size is a little different. Now they are on aluminum foil for a reason. I am going to wrap them up and then I'm going to burn each and we will see if they look any different. Okay, so there's blue flame there. This is the first one. This is salt. And we're going to let it cook for a while and see if anything happens. Now, ionic compounds have high melting points. So, matter of fact, I think it's even higher than the aluminum foil. So if we let it cook for a while, we might even be able to get, oh look, it's falling out. Do you see it's still crystals? It's not catching on fire, it's just falling out. So you can tell that it hasn't changed. It hasn't melted. Ionic compounds have a high melting point. Now, let's compare that. Take the sugar now, and let's put the sugar on there and see what happens. I hear sizzling. Didn't hear that before. I see smoke. And I think it's actually on fire a bit. Let's see. Move this over. Yeah, it's actually even burning a little bit. There must be a hole in the bottom of the bag, maybe, around the edge. Let's keep going. I'm going to turn the fire off, and then I'll let you look inside both of these. Yeah, that's definitely burning. Okay, let's get it out. All right, turn off the gas. Now let's see. If we open up the salt, if there's any left, because it all pretty much spilled out the bottom. Anyway, you can see there's the salt, looks the same. Now let's see if this looks like white crystal still. I can tell you one thing, it doesn't smell like it used to. Oh, hey, what happened to the sugar? Looks to me like it burned. So it melted, caught on fire, and burned. So right there is a pretty good example of ionic compounds versus covalent compounds. All right, now I want to also look over here at a couple of things, but first let me turn off. Okay, so another property of ionic compounds is that they dissolve in water and they break apart into cations, which are positively charged, and anions, which are negatively charged. Okay? Now I'm going to do an experiment that I can show you that salt will conduct electricity when it is dissolved, but sugar won't. And what we're using is just your standard Morton iodized salt and sucrose, which is table sugar. It's the same stuff that I burned a minute ago. All right, so in order for this to work, the conductivity meter can't light up when I put it in before the sugar. So I will test that, but I wanted to show you what happens with tap water. Do you see that? Tap water isn't pure, so I can't use tap water. I have to clean this. Sorry, I know it's not a great video, but I'm going to use distilled water. Now, distilled water is from that distillation apparatus. It's boiled and condensed, so it should be clean. All right, do you notice? It's not lighting up when I put it in. Let's check the salt water before. Ooh, is there a little bit of light there? There might have been. All right, it probably wasn't clean. All right, so I will have to go back and clean those. I will come back in a minute. All right, we're going to try this again. Hopefully this will work this time. I think what happened is when I was burning a hole through the aluminum foil that contained the salt and shaking it, some crystals fell in, because these were really close, just off camera. Okay, that's touching the water. It's not lighting up. That was the salt water. That it's not salt water yet, it's going to be salt water. Okay, that's the sugar water. Touching the water, not lighting up. Now, what are we going to do? We're going to add a little bit of salt to the salt water. Don't need much. And we're going to add a little bit of sugar to the sugar water. And I'm going to pause and stir until this stuff is dissolved, and then we'll test it again. Now, there's the salt water, there's the sugar water. Let's look. Everything dissolved in the salt water? Yep. Everything dissolved in the sugar water? Yep. So let's see if we see anything light up when we put this in the salt water. Oh, wow. Lighting up like crazy. Now, I'm actually going to rinse this in the distilled water over here because I want to make sure I didn't get any salt. Don't get any salt into the next one. Dry a little bit. Now, if the sugar is 100% pure, it won't light up. Now, the problem is to buy 100% pure sugar is expensive. This stuff is about 99% pure, so we might get a tiny bit of light, but hopefully it won't light up at all. I don't know. I don't think it's lighting up at all. But anyway, the real point of this is that you can see a big difference between salt water and sugar water and conductivity of electricity. Ionic compounds break apart in salt water, conduct electricity because they have cations and anions, which have charges. Sugar is a covalent compound made of carbon, hydrogen, and oxygen. It does not break apart into ions. It does not have a charge, so it cannot conduct electricity. The other property we tested was melting point and whether they burn. And you saw that salt has a very high melting point. We couldn't even melt it using the Bunsen burner, and that sucrose, which is table sugar, not only melted, it caught on fire, which is another characteristic of organic of covalent compounds.